All right, so problem 6 through 10 on the first test, practicing again, pure mechanics. Equation of a line perpendicular to 5x minus 2y equals 53. That also passes through the 0.47. So 0.47, y equals x minus 4 plus 7. And now all we have to do is find that ratio of change. Did a video on this. It's out there. Why? All about the ratio of change in linear function. In this problem, we don't care about the constant. I like to divide by positive y's. So I'm going to move 2x to the 2y to the other side. Negative 2y becomes positive. And so the ratio of change in this problem is 5 to 2. Therefore, the perpendicular is minus 2 to 5. Constant doesn't matter. Y equals negative 250. I'll write x plus 2 plus 50. That gets it. The linear function is going to pass through that point now. I'm going to move the 8x to the other side. 3y equals negative 8x. Therefore, y is equal to the multiplier negative 8/3 x. There's my conversion ratio. The perpendicular to negative 8/3 is 3 to 8. Moving right along. Constant doesn't matter through AB. Y equals x minus a plus b. A gets me b. And I'm going to move the 2y to the other side. 2y, 9x. So 9 over 2 is my ratio of change. Therefore, minus 2/9 is my perpendicular. Constant doesn't matter. Let's have this pass through the point I there. So I'm going to write x minus I. Oh, I capitalized it. Better capitalize it here. There. I prefer this, that. I don't know why I said hi there, but I did. Hi there. Minus 17y goes to the other side as positive 17. 4x can stay on the left. 4/17 x equals y. My ratio of change is 4/17. Therefore, I want my y equals to be negative 17 over 4. And one more. My goodness, one more. Getting our reps in. Okay, I think I said reps. Getting our reps in. So I'll bring the negative to the other side. And I do this so that students make fewer sign errors. Dividing by 53, 29 over 53 is my ratio of conversion. Therefore, negative 53 over 29 is the slope that I want. Minus buffer, x minus buffer. You give me a buffer, I'll give you a low. All right, now problem number 7 on the test. Functional notation. F of x is another way of saying y, and I'm going to use the number 9 is going to replace the letter x. That's the number I'm going to work with. 8 times 9 minus 3. 72 minus 3 looks to be 69. That's that one. G of x, different calculation. G of negative 8, so minus 3/5 times negative 8 minus 4. And negative times a negative is a positive. 24/5 minus, I need to write the number 4 in terms of fifths. I do believe it's 20, so my final answer is 4/5. F of x is a logarithm calculation, and I want f of 0. I guess that means I'm going to replace this x with a 0. And that gets me 2 log base 3 of 9 plus 5. All right, so go back to the original, but that's what I get. I'm going to do the log first. What's the exponent you put on top of 3 to get a 9 to 2? 2 times 2 is 4. 4 plus 5 is 9. You give me a 0, I'll give you a 9. P of x, little exponential function. Calculation. Let's put negative 3 in for x. 2 to the negative 3 minus 5 is equal to 1/8 minus 5. But I got to write 5 in terms of eighths. I think that's 40. And so therefore my final answer minus 39 over 8. That means we're doing some calculations. And now I've got a 0, so 9 times 0, that's nice. Products times 0, I like those. Minus 5 squared is 25 plus 4 to the 0. And I hope you know that anything to the 0 is 1. So 26. Now we're on problem number 8. Oh, g of x equals 5. I didn't give you an x value. And this is basically saying y equals 5. Oh, that means I can replace g of x with its new name. 2x minus 9. That's another name for g of x. And I want that to equal 5. Sure looks like I'm trying to find when this line hits a height of 5. 2x equals 14. It looks like it happens when x is 7. Looks like I got to find out when this equals 10. Yep, f of x is that calculation, and I want that calculation to equal 10. So minus 3/4 x minus 2 equals 10. I'm going to add 2. I'm going to multiply by 4. I'm going to divide by negative 3. And 4 plus 8 is 12, so 3 goes into that. So it looks like it goes 16 times. So minus 16. That takes care of that multiplication. All right, p of x equals 32. Oh, looks like I got another equation. 2 to the x equals 32. Well, I've worked enough with that I know that's 5. Yeah, 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. Yes, I do believe it's 5. F of c equals 9/5 c minus 0, so let's find f of 10. So what did I just give you from the last lesson set? 1 through 5. Celsius gives us Fahrenheit. So Fahrenheit based on the Celsius temperature. I don't need that minus sign there, so it's really 9/5 c plus 32. So how many times does 5 go into 10? I do believe twice. So over in India, 18 and 32 tells me that if you give me Celsius at 10 degrees, I'll give you Fahrenheit at 50 degrees. So it says 10 over there. I got a sense that it's around 50 degrees. Keep the sweater on. Okay, P of G, what have I got up here? P of, oh, yes, I'm using letters, yes. What's 315 minus, oh yeah, Cumberland Farms, $3.15 per gallon. But if you got a card, they take 5 cents off, something like that. I don't know, I got an electric car, so I don't bother with that anymore. You know, these are like terms. I might even simplify that first and say 3.10, $3.10 per gallon. And I want a certain number of gallons, which I didn't even say. This is solving. What are we doing here? We were evaluating. Solving back there. I've lost track of what we're doing. I guess it was an evaluation. No, that was a solve. That was a solve. Huh. That was a solve. This was a, I plugged in 10 here. It kind of changed up. I'm not sure what exactly. I think I wanted to get this to equal something. So P of G equals, now I got to think a little bit. How about that? So I don't have to think so much. 620, 6.20. All right, so now I got to solve this, simplifying it. 3.1 G equals 6.20. I hope you can see G equals 2. So 2 gallons of gas is going to cost me $6.20. All right, some exponential work. Sure would be nice if we had the same base. Oh, I know 1 over 27 is 3 to the negative 3. And I know 9 is 3 squared. And I can raise that to the x. Sure looks like 2x equals negative 3 halves. No. Oh, sorry, 2x equals negative 3. All right, so negative 3 halves is our x value. Let's see, negative 3 halves. What are the operations? Square root of 9 is 3, and 3 to the negative 3 is 1 over 27. You know, I think x equaling minus 3 halves gets the job done. All right, so let's get a little more exponential practice in. My trusty science card. Yeah. Okay, I think we can see these easy enough. 25 to the x, again, that's another 5 to the 2x. This is another 5 to the -3, same problem. -3/2, same outcome. 1/3 to the x is the same thing as 3 to the -x. And 81 is 3 to the 4. Sure looks like x is -4. So let's see, 1/3 to the -4, what would happen? Well, if I did the minus, then that's 3 to the 4. And 3 times 3 is 9, times 3 is 27, times 3 is 81. I like that answer. Okay, and 81 we just said is 3 to the 4. So why don't we just use that? And say 3 to the 4x equals 3 to the 3. Sure looks like x is equal to 4/3. That's the cube root 4 times. Cube root of 81. Oh, I don't like that. Oh, I said the wrong thing. Good thing I checked it. I'm dividing by 4, right? That was careless, tired brain. 3/4. Yeah, we just did this over here. All right, so if I take the 4th root of this, I'm going to get one of these factors, 3. All right, 4 to the x equals 1/8. Yep, see that? Well, 4 is 2 to the 2x. 8 is 2 to the -3. Boy, I like -3/2 here today. Oh yeah, square root of 4 cubed and flipped. Square root of 4, 2, 2 cubed, 8, flipped, 1/8. All right, now we got completing the square. I think we'll move this to the desk. Okay, so completing the square, there's videos on it out there that you supposedly already looked at, but the views on my YouTube channel suggest that we're not getting all of the students to look at the videos. And maybe that's why the scores aren't going up so much. And maybe that's why I'm going to start testing every other day. All right, so reshaping a rectangle into a square, because if you're going to solve some equations, you can't use a square root on any other rectangle than a square. So just mechanics here. X plus 4 squared, get rid of that constant, -16, write the constant that's there. This is acceptable. X squared minus 20x for coefficients of 1. Cut it in half. It's negative, it stays negative. Square. Squaring that gets me 100. Get rid of that 100, bring in the 7. And I'm suggesting that x squared minus 20x could have been written as x minus 10 squared minus 93. Let's put a 10 in and see if that really works. 10 gets rid of this, gets me minus 93 on this side. This is 100 minus 200 plus 7 gets me minus 100 plus 7. Yes, they are indeed the same calculation. Oh, that should look familiar. That's putting a quadratic in graphing form. Maybe that's another name for completing the square. X plus 2 squared minus 4 minus 19 will get you a check from me. X squared minus 16, x plus 1 is x minus 8 plus 1. Now, we could do the textbook completing the square for a problem like this. Right? Now put a little y in front of this. Right? Completing the square is putting it in graphing form. But we're not going to do that here. We're not going to factor out the 3. Right? There's no reason to do that. People have trouble with that. So why don't we just take what's given and find the vertex. Minus b over 2a, in this case is 12 divided by 3 is double 6, so 12 divided by 6 is 2. So I could write minus 2. And if you want, for a shortcut, you can get rid of the constant. That's 4 times 3 is 12. You can get rid of that 12, just like you did before, and add 7. And you'll get a check from me. I prefer this, actually. I like doing it that way. That's what you'll see me doing in class. Remember, up here, we can see a 0 gets us a 7. I will talk about this one, right? But if I put 0 in here, I get 3 times 0 minus 2 squared, and that gets me 12. Well, 12 isn't 7. So I get rid of that 12, and I write the 7. I don't have to think. All right, there's your next 5 problems of practice. All right, next will come 11 through 15.